All right, here's the review 2 answers for our Module 1 Topic C. Our second review. Here we go. Indicate whether each of the following equations is sure to have a solution set of all real numbers, and explain your answers for each. Well, I'm just going to see if I can make both sides of the equation equal to each other. If I can, then it's all real numbers. If it's not true, then it's not. So I'm going to use the distributive property, and that's going to give me 5 times x is 5x, and a 5 times a positive 2 is a 10. So I get 5x plus 10 equals 5x plus 10, and that's a yes, all real numbers, because they're equal to each other. Part B, no, because x plus 2 is not the same as x plus 3. And if I subtract x from both sides, they would go away, and I would get 2 is equal to 3, and that's not true. So no, there's no solution here, and the solution set is not all real numbers. And then lastly, distributive property again, this would give me 3x squared plus 6x, and if I change the order of my right side, I would get the same thing. 3x squared plus 6x. So since they equal each other, that is a yes. All real numbers are the solutions. All right, number 2. Determine which of the following equations have the same solution set by recognizing properties rather than solving. Well, I'd like to see if I could change these into each other. So the first thing that I'm going to do is try to get rid of this denominator. I would rather not have that 5 there, so I'm gonna multiply through by 5 so I can clear the fractions. So 5 times 6x is a 30x, and 5 times 9 is 45, and then 5 times 13 fifths. Well, the 5s would cancel out, so I just get 13. And then 5 times x is a negative x is a negative 5x. And then, bingo, that is the same as that. And the others are not going to be the same. Because if let's just check it. If I rewrote this as 26 minus 10x, I could multiply this by 2 over here on this side. I could multiply everything by 2, but 2 times 30x would be 60x, and that's not what I have here. So it's just it's just A and C that are the same. Number 3, solve the equation for x, and tell me what steps are going on. First thing I would do is distributive property. So 3 times 5 is 15x. 3 times a negative 2 is a negative 6. That's minus 7 is equal to 3 plus 10x. The only thing I did here was distributive property. Okay, that's the first thing. Next, I would combine like terms. 15x, and put these two together. That gives me a negative 13 is equal to 3 plus 10x. That's combined like terms. Okay, there's that. And continuing, let's get all the x's on one side. So subtract 10x from both sides. That gives me 5x minus 13 is equal to 3. And that's the additive identity property. All right, and then let's see what else. I can add 13 to both sides. That gives me 5x equals 16. And that's also additive identity property. And let's see, continuing, divide by 5. And that's x equals 16 fifths. And that is the multiplicative identity property. And that's my answer, x equals 16/5. Number 4, consider the equation x plus 2 equals 2x plus 8. Show that adding x plus 2 to both sides doesn't change the solution set. Well, the first thing I need to know is what is the solution set. So I'm just going to solve this. X plus 2 is equal to 2x plus 8. And I'm just going to try to isolate the x. So get them all on one side. 2 equals x plus 8. Subtract 8. X equals a negative 6. So that's the solution set. X is negative 6. And then we're just going to take that original equation, add x plus 2 to both sides, and see if we get the same thing. So I'm going to take x plus 2, and I'm going to add x plus 2. And then I'm going to take the 2x plus 8, and then I'm going to add x plus 2. And we're going to see if we get the same thing. So combined like terms, this is 2x plus 4 is equal to, combined like terms, that's 3x plus 10. And then I'm just going to work on getting x isolated. So move them all to one side. That gives me 4 equals x plus 10. Subtract 10. And that gives me x equals 4 minus 10 is a negative 6. So yes, I get the same solution. Adding x plus 2 to both sides doesn't change a thing. Number 5, find the solution set to each inequality and express the solution graphically on the number line. Well, I'm just going to solve it like it's an equation and then put the answer on a number line. So let's do that. I would subtract 2x from both sides. That would give me a negative 6 is less than 5x plus 4. And then subtract 4 from both sides. And let's put that over here. That's a negative 10 is less than 5x. And then divide each side by 5. That would give me x is greater than negative 2. X is greater than negative 2. And put that on a number line. Make sure negative 2 is on there somewhere. And x is greater than negative 2 means not negative 2, but everything bigger. So that's this. All right. Part B. Distributive property first. X squared plus 4x minus 20, right? I just did 4 times x and 4 times a negative 5, is greater than or equal to x squared plus 8. And then let's work on getting the x's all by themselves. Well, I can subtract x squared from both sides. That leaves me with 4x minus 20 is greater than or equal to 8. And then I could add 20. And that gives me 4x is greater than or equal to 28. And then divide by 4. And that gives me x is greater than or equal to 7. And then just put that on a number line. Well, number line, make sure 7 is somewhere on there. 6 would be to the left, 8 would be to the right. Greater than or equal to 7 means I include the 7, so solid dot, shading in the dot, if you will, on 7. And everything bigger, that's this way. Okay, it will look like that. Number 6. Fergus was absent for today's lesson and asked you to explain why. Why the solution to negative 1/3 x is greater than 3 is x is less than negative 9. Well, if we were to solve this, negative 1/3 x is greater than 3. What I would have to do to get the answer is I would have to multiply by the reciprocal of negative 1/3, which would be negative 3 over 1. And if I do that, I have to balance the equation and do that on both sides. So negative 3 over 1 times negative 1/3 gives me a positive 3/3, which is a positive 1x, or they cancel. But when I multiply by a negative, I have to flip the inequality symbol. So now it's x is less than whatever I get on the right side, and that is a 3 times a negative 3 is a negative 9. So x is less than negative 9. All right, number 7, solve the system and graph the solution set on a number line. Well, it's or, so either one of these can be true and make the system true. So we just treat these separately. I'm going to solve x minus 7 equals 5 by adding 7 to both sides. X equals 12, that's one solution. And then I'm going to solve 4x plus 2 equals 10. Subtract 2. 4x equals 8. Divide by 4. X equals 2. So I have two solutions. Either one can be true, and when I put them on a number line, I just need them both on here. 2, 4, 6, 8, 10, 12. That would work. X equals 12 is a solid dot on 12, and x equals 2 is a solid dot on 2. The end. Number 8. Saltwater aquariums must have a certain amount of salt content. The United States standard for safe levels of salt in an aquarium is at least 35 parts per thousand and less than 45 parts per thousand. Write a compound inequality for the acceptable range of salt levels. Well, if I said X is going to stand for my salt levels, then I can write the inequality. I could say X has to be, well, at least 35 means it has to be, it could be 35 or bigger. So greater than or equal to 35 is the first part of my inequality. And then it also has to be less than 45. So X is less than 45, and that is the compound inequality. X is less than 45, and X has to be greater than or equal to 35 would be correct. Number 9, solve each compound inequality for X and graph the solution on a number line. So now we're solving the inequality just like it's an equation. So I would subtract 3. That would give me 3x is less than 12. And then divide by 3. And that would give me x is less than 4. So that's one possibility. And then if I solve the other one, let's see, let me get a different color here. I would subtract 3. And that would give me a negative 2x is less than a negative 8. And then divide by a negative 2. Remember, when we divide by a negative, I have to flip the inequality. So this is x is greater than negative 8 divided by negative 2 is a positive 4. And when I graph, I have to say x is greater than, x is less than 4. If that's a 4, 3, 5, less than 4, not 4, but everything's smaller. Or x is greater than 4, not 4, but everything bigger. That's the solution set. Everything shaded, which is every number except 4. And either thing, any possibility is good. Bigger than 4 or less than 4. All right, and then the last one, I would rewrite this. 1 is less than or equal to 1/3 x, which is less than or equal to 2. And I would just multiply everything by the reciprocal of 1/3, which means multiply everything by 3. So that gives me 3 is less than or equal to, 3 times 1/3 is just 1x, and 3 times 2 is 6. X is less than or equal to 6. Put those both on a number line. 3, 4, 5, 6, and put them both on there. So greater than or equal to 3 would be solid dot on 3 and bigger, and less than or equal to 6 would be solid dot on 6. We want to include the 6, so shade it in, and smaller, and the intersection in the middle is where all of the answers lie. Anything 3 or bigger, up to 6. Number 10, find the solution set to the equation 5x squared plus 20x equals 0. Well, this is where I'm going to find the greatest common factor of those two terms. So I know 5 goes into both, and it looks like x goes into both. So 5x squared divided by x, divided by 5x is just x. And then 20x divided by 5x, well, that's just a positive 4. And that's equal to 0. And now I'm in good shape because if either one of these is equal to 0, then the whole thing's equal to 0. So I just take each one and I say, what if 5x equals 0? Well, divide by 5, we get x equals 0. That's one solution. And what if x plus 4 equals 0? Well, subtract 4 from both sides and we get x equals a negative 4. That's a possible solution. If x is 0, I get a true equation, and if x is negative 4, I get a true equation. Number 11. Rewrite the equation x minus 1 over x minus 5 equals 6 as a system of equations. Well, the system is the same equation, x minus 1 over x minus 5 equals 6, and x cannot equal 5. Because if I put a 5 in for that x, I get 5 minus 5 is 0, and I cannot have a 0 in the denominator. So that's the system, and then solve for x. Well, if I'm going to solve for x, I need to first clear the denominators. I cannot have a fraction here. So I'm going to multiply everything by x minus 5. I want to get rid of the denominator here, so I'm going to multiply everything by x minus 5. So if I do that, the x minus 5s cancel, and I get x minus 1 on the left side. And on the right side, I get 6 times x minus 5, the quantity x minus 5. And then I can go about isolating the variables because I don't have any denominators anymore. So x minus 1 equals distributive property 6x minus 30. Subtract x. We get a negative 1 is equal to 5x minus 30. Add 30 to both sides. We get 29 is equal to 5x. And divide each side by 5. And we get x equals 29 fifths. 29 fifths is not 5, so it's a good answer. Here's 12 and 13. If you have the formula a equals 1/2 of b times h, solve a when b is 12 and h is 7. All right, so a equals 1/2 times b, which is 12, times h, which is 7. Well, half of 12 is 6 times 7, and 6 times 7 is 42. So area, or A, which is area, A equals 42. All right, and then can we rearrange the formula to solve for B? Well, it's originally this, and I would like to just have B equals something. So I just need to isolate the B. Well, these are all multiplying together, so but there's a fraction, so I'd like to get rid of the fraction. Let's do that first. Let's multiply through by 2. So this would be 2a equals just b times h, because the 2's would cancel, right? 1 times b times h is just b times h. And now I can just divide by h. And that gives me b equals 2a divided by h. And that is the formula when b is isolated. All right, number 14. Write a system of inequalities that represents the shaded region. Well, in order to do this, I need to know the two equations of the lines, and then I have to think of them as inequalities so that I can figure out where the shaded part is. So let's first think of the lines as equations and find out what they would be. Well, if I'm talking about the diagonal line, it crosses at positive 6. So I know it's going to be y equals something times x plus 6 because it's going to cross at positive 6. And then I just need the slope. Well, the slope is down 2, right 2. Well, down 2, right 2 is just a negative 1. So y equals negative x plus 6 is the equation. But it's not really an equation, so I'm gonna get rid of that equal sign, and I'm gonna decide what my symbol is gonna be there. Well, it's a solid line, so I know the equal sign is gonna be involved. But then I have to decide whether it's gonna be a greater than or a less than. So I need to find one point that's gonna be on that shaded side, and it looks like I could use that one. This one right here is 10, negative 2. That's in the shaded part. It's on the right side of my line. So I'm going to use the point 10, negative 2, and I'm going to plug it into what I think my equation is going to be. That's y is something or equal to a negative x value, which is my x value, remember, is a 10. And my y value is a negative 2. So that's a negative 10. And the y value, is a negative 2. So I'm going to replace that with a negative 2. Negative 2 is something or equal to negative 10 plus 6. So then I have negative 2 is something or equal to a negative 10, and a positive 6 is a negative 4. And then I just decide, is negative 2 bigger than negative 4 or smaller? And the answer is it's bigger. So that's my symbol. Y is greater than or equal to negative x plus 6 is the first inequality in my system. And then I have to check the other line. Well, the other line is this. It's a dashed line, and it's horizontal. And that means it doesn't matter what x is, y is always 1. So I'm going to have a y here and a 1 over here. Okay, because it's stubborn, right? Doesn't matter what x is. If x is 0, y is negative 1. We got a point there. If x is 10, y is 1. We've got a point there. If x is 16, y is 1. It really doesn't matter what x is. So it's something like this. And then I just have to think about what is my line. Well, it's dashed. So I don't want the equal sign involved. So there's not going to be an equal sign. It's either going to be less than or greater than. I just have to choose the right one. And I just have to test it. So I could use the same point and test this. I could say, well, x is 10 and y is negative 2. That's in the shaded region. So let's see, what makes that true. So if I use this y is something to 1, and I replace y with a negative 2 is something to 1, I would have to say negative 2 is less than 1. So that's my sign. Y is less than 1. And that is the system. All right, 15, write a system of inequalities that represents the shaded region on the graph below. Well, same thing. I need some equations like their equations first, then I'll decide what type of symbol that I need. And I'm going to do that just by, we'll start with the diagonal line. I see that it crosses the y-axis at negative 5. So it's going to be y is something, mx, the slope is going to be on there somewhere, and then I'm going to cross at negative 5. So it's that. And then I just need the slope. Well, the slope would be, if I went up 1 and right 1, I would be on the line again. So that's up 1, right 1. Well, that's just 1x, or x. So that is the equation if I just wanted to say equal sign, but I don't want an equal sign. It's an inequality. So I noticed that my line is dashed, which means there's not going to be an equal sign involved. And then I just have to figure out the inequality sign. Well, I'm going to choose a point that's in the shaded region. And it looks like I could go maybe 6, I don't know, let's just choose 6, -6. That's in the shaded region. 6, -6. X value 6, Y value -6. And then we'll plug it in to this inequality. We'll think about it and see what the symbol would have to be. Well, if my Y value is a -6 and my X value is a 6, I get -6 is something to 6 minus 5 is 1. And -6 is less than 1, so that's my symbol. Y is less than X minus 5. So that's that one. And then let's see about this vertical line. On my vertical line, it really doesn't matter what X is, what Y is. X is always a -1, so it's X is something to -1. I just have to figure out what the symbol is. Well, if I choose the same point, I can do that. Choose the same point, I would say my X value is a 6, and that has some relation to -1. So what is it? Well, 6 is greater than -1, so that's my symbol. X is greater than -1. Okay, and if we graph that, that would be everything shaded to the right, right? All this over here. And if we graph the other one, it'd be everything shaded in this direction. And the overlap is where our solutions lie. It's that the purple area. All right, that is the review part 2. Use that to help you study for the test, and I'll catch you again next time.